Okay, grade 10s calling upon you. Have a session for grade 10s. Very important session, this one. Okay. Okay, guys. Yeah, I know we are still trying to shake off it being the 25th and stuff. And I mean, we had a beautiful Christmas. I'm hoping, guys, you had a beautiful Christmas. Right now, I'm just gonna jump into some grade 10 syllabus kind of work. I initially had a live earlier on, I think it was in the week, where we were looking at like numbers and the number system for grade 10s. And then we actually jumped into looking at relationships between numbers, and specifically looked at questions such as this, where you are given an expression with a radical, and then they ask you for which value of x will r be undefined and non-real. We basically answered questions of this nature, and the live session for this, you can find the full video that I did for this particular lesson in my YouTube channel. We also looked at the number system in that video. All right. Yes, thank you so much for that. I am feeling well. So we looked at the number system with that. So all of that content can be found in the channel, my YouTube channel. The link is in my bio. You guys can jump on and hop on there, and you can see the lesson that was covered then. I just want to pick up from where I left off from that lesson, and I'm going to continue by looking at the following few questions. All right, I think I'm going to have an hour lesson with you guys, and then that will be that. Okay, I'm not intending to stay for that long, so an hour, you can hold me to it. The time now is 7:46. At 8:46, guys, you and I need to not be in this live session together. Okay, so let's look at this. Okay, we are given z is equal to, we are then given the square root. Okay, yeah, the square root, and then in the numerator we have x plus 1, in the denominator we have x minus 3 into x plus 2. Right, and the first question that is asked is, for which values of x is z? Remember, guys, when you're speaking about z here, z is actually equal to this. So when you talk about z, you are talking about the square root of x plus 1 over x minus 3 into x plus 2. That is what z is. All right, so now the question here is saying, for which values? So we want the values of what? Of x. Which values of x is z equal to 0? They want the values of x by which z will be equal to 0. All right, so I hope you guys sort of like are tuning into what I'm saying here. Question is saying for which values of x we want the x values that will make z equal to 0. So in order to find those values of x, right, from the previous live session that I had with the grade 10s, whenever we say for which values of x is z equal to 0, what that means is we look at the numerator. Because remember guys, if in this fraction, in the numerator we have 0, we know that 0 divided by anything will give us an answer which is 0. So our focus here, all right, becomes the expression in the numerator. And what do we do to the expression in the numerator? Because that's where our focus should be because of the question. Let me just give it to you again. We are given z is equal to the square root of x plus 1 in the numerator over x minus 3 into x plus 2 in the denominator. And the question is saying which values of x is z going to be equal to 0? And what I'm saying to you here is the concept behind this question is whenever we have 0 in the numerator divided by anything, guys, it can be anything. 0 divided by anything. The only condition is that we don't want to have 0 in the denominator. But 0 divided by any number except 0 in the denominator, 0 divided by any number will always give us an answer that is what? That is 0. So in other words, if there is a 0 in the numerator, 0 divided by anything will give us z being equal to 0. So go back to the question. We are asked for which values of x is z equal to 0. Are we together? Remember guys, 0 divided by 0, no. 0 divided by 0 we know is undefined. Okay, so that's why I was saying the exception here is that in the denominator we can't have 0. All right, but for this particular question we know that our focus is that in the numerator we must have 0, but in the denominator we can have any number except the number 0. Why? Because 0 divided by any number, as long as it is not 0 in the denominator, will give us a what? An answer of 0. So if we come to the question is saying, given this expression, for which values of x is z, here is z is this expression, going to be equal to 0. So what I'm saying is, step number 1, our focus should be the expression in the numerator. So we go to our equation here, z is equal to the square root of x plus 1. What do we have in the numerator? In the numerator we have x plus 1. Yes, we acknowledge that this x plus 1 is underneath a square root, but in the numerator we have x plus 1. So what do we do to that numerator? We take that numerator, and remember, what condition did I say needs to be there in order for us to have z be equal to 0? Remember, in the numerator, as long as in the numerator we have 0, divided by any number will give us 0. In other words, 0 divided by any number will give us a z that is equal to 0. We want the values of x in this expression that will give us something equal to 0, whereby z will be equal to 0. So I focus on the expression in the numerator. Then thereafter, what do? I take that expression, I make it equal to 0, which is basically what we want most. In the numerator we must have 0, so we are going to write down the expression that is x plus 1 in the numerator and then make it equal to 0. Then thereafter, what do? we can go ahead, step number 2, and solve for x. Okay. When we solve for x, this becomes x is equal to, remember, plus 1, we can transpose to the right hand side. When plus 1 is moved to the right hand side, what happens to plus 1? The plus 1 becomes negative 1. Therefore, the value of x, the value of x that we are looking for, which will basically make z be equal to 0, is actually x being negative 1. And we can check this out actually very quickly. So if you take this x, which is negative 1, and we substitute it there in the numerator, what happens? In the place of x, we substitute negative 1. This becomes negative 1 plus 1. What does negative 1 plus 1 give us in the numerator? What do we get when we take negative 1 and add 1 to it? What do we get in the numerator? Negative 1 plus 1 is equal to? Exactly, Lideline. Negative 1 plus 1 is going to be 0. That means we are going to really have 0 in the numerator. And guys, do you know what? 0 divided by anything will ultimately mean that z is actually equal to 0, which is basically meaning that indeed when x is negative 1, that is when z is equal to 0. We wanted at the end of the day the values of x whereby z is equal to 0. So as I said to you, step number 1, we know that 0 divided by anything in a fraction gives us 0. So our focus then must be in the expression in the numerator. We take that expression in the numerator, which in this case is x plus 1. We make it equal to 0 because in the numerator, when there is 0, that is when we can actually have z being equal to 0. Then we solve for x. X then gives us an answer of what? Negative 1. So when x is equal to negative 1, guys, that is when z is actually going to be equal to what? To 0. Our focus for a question such as this must always be that the expression in the numerator is equated to 0. Then we solve for x. Okay. I hope that makes sense. All right. So guys, with that said, that is basically how we are able to answer questions such as this. I see someone in the comment section said, can we use the denominator to get the answer? And the answer to that is that we cannot use the denominator. Remember guys, why are we using the numerator? Why are we using the numerator, guys? The reason why we use the numerator is because the concept of division to get 0 is that 0 divided by anything. So once again, our focus here, what do you see in the numerator? Okay, in the numerator we should have 0, because if there is a 0 in the numerator divided by anything, we get 0. Are we together? And the question here is saying for which values of x is z okay guys, I'm sorry about the noise in the background. It's just that in the area where I'm at, the noise cannot be controlled like the music. So these people are really like annoying. Okay, so for which values of x is z equal to 0? As I said guys, our focus is on the numerator, making the expression in the numerator equal to 0. Then we take the expression that is in the numerator, whatever it is, we equate it to 0. Then we solve for x. So x is equal to negative 1, and that is basically the answer. we can't use the denominator because we are not interested in the denominator being 0. Remember guys, when there is 0 in the denominator, that means the entire expression is undefined. We don't want for when z is undefined. We want for when z is equal to 0. Which values of x is z going to be equal to 0? And equal to 0 means the 0 must be in the denominator alone. I mean in the numerator alone. The 0 must be in the numerator alone. Okay, that's what we are interested in. Okay, let's go on to the next question here. 2.2. Okay, the concept of undefined. Now, the other next question is saying, for which values of x is z undefined? I repeat, for which values of x is z here, undefined? Now, when we think about the concept of undefined, this time round, what are we going to focus on? Are we going to focus on the numerator, or are we going to focus on the denominator? Because remember, when we said for which values of x is z equal to 0, our focus was on the numerator, taking that expression, making it equal to 0, then solving for x. The follow-up question is saying for which values of x is z undefined. So for undefined, guys, where is our focus? Is it in the numerator, or is our focus on the denominator? What do you guys think? What are your thoughts? What does undefined mean? Okay, thank you so much, 26. Our focus must be on the denominator. The reason why that is the case is because any number when it's over 0, so any number divided by 0, guys, any number over 0, that's what it means for it to be undefined. So now our focus is going to be here in the denominator. All right, not the numerator, but the denominator. So we go to our expression, we go and check out what is in the denominator. Okay, do you see what is in the denominator? Okay, I hope you guys do. So we are simply going to say x minus 3 into x plus 2. Okay, x minus 3 into x plus 2. So we've just harvested, or we've just taken what is in the denominator, which is x minus 3 into x plus 2. Then what do we simply do after that? We make that equal to 0. So x minus 3 into x plus 2, we make that equal to 0. Okay, then we solve for x. Yes, this is grade 10, guys. This is grade 10. Okay, so when we solve for x, guys, then you should be able to remember from grade 9. You guys did questions like this, where you have to solve for x. X minus 3 into x plus 2 is equal to 0. I'm sure you guys can solve for x from here. What do you do when you have two factors equated to 0? Yeah, you can comment for me in the comment section there. Okay, guys, x minus 3 into x plus 2 is equal to 0. At this stage, we have factors x minus 3, x plus 2 equal to 0. All right, so we are at this stage. Okay, then the next thing we need to do is apply what I call the zero factor law. When you have two factors multiplied to each other and they are equated to 0, all you can simply do, which is your next step, is you take your x minus 3, make it equal to 0. You take your x plus 2, you make it equal to 0, because this is a product of factors equated to 0. Okay, then you solve these two independently. Okay, then all you do is you transpose the minus 3, take it over to the other side, it's positive 3, transpose the positive 2, take it over to the other side, it becomes negative 2. So these are your two answers: x is equal to 3 or x is equal to negative 2. These are the values of x for which this expression here will be undefined. These are the values of x. Remember, if you take this 3 and you substitute it here in the place of x, 3 minus 3 here becomes 0. Okay, and 0 multiplied by anything is 0 in the denominator. So x is equal to 3 is one of the values of x that will make this whole entire thing undefined. In other words, it will make the denominator become 0. Or if you take this negative 2, you substitute it in the place of x here, negative 2 plus 2 gives you what? Gives you 0. And then 0 times that will give you a what? A 0 in the denominator. So these two values both assist or qualify in making the value of x, all right, and making the z here become undefined. Okay, so please guys, these two concepts are important. What does undefined mean? Undefined means division by 0 in the denominator. So that's why when we are being asked this question, for which values of x is z undefined, our focus is on the denominator. That's where our focus is, because when we talk about undefined, we are talking about when any number in the numerator is divided by 0 in the denominator. Make sense? So therefore you take the expression in the denominator, which is here x minus 3 into x plus 2, you equate that to 0, and then from there you determine the values of x that will give you this 0 in the denominator. And the two values here are x is equal to 3 or x is equal to negative 2. And all you guys are doing here is you are simply applying your knowledge of solve for x that you learned last year in grade 9. Because in grade 9 you guys learned about, okay, that important concept. Okay, so I hope you guys sort of like understand why we say that these two values here would lead to an answer whereby we say that the fraction is undefined. These are the two values, and these two values are actually legitimately true, because even if you took 3, let's say you took this 3 and you decide to take it first and add it there, the 3 plus 1, that will be 4, right? So you're going to have a positive number at the top. Then in the denominator, you are simply going to have what, guys? You are simply going to have a 3 minus 3, which will lead you to 0 being available in the denominator, because whatever you get, 3 minus 3 here will give you 0, 3 plus 2 will give you 5, but 0 times 5 will give you 0 in the denominator. And we know that any number divided by 0 is undefined. So that's why we say x is equal to 3 qualifies as an answer. Also, if we take x is equal to negative 2, yes, you'll take negative 2 there, you say negative 2 plus 1, you'll get a negative 1 in the what? In the denominator. Then here in the in the numerator, sorry. Then you take that negative 2, you take it, you put it there in the denominator. Negative 2 minus 3 gives you negative 5, and then negative 2 plus 2 gives you 0. You multiply 0 with that number, you will get a 0 in the denominator. That negative number divided by 0 before you even square root it will lead to an undefined fraction. You see? So that's why both answers qualify. Both of them, they are valid in our answer. Okay, so I need you guys to understand this. Okay, remember the first question said for which values of x is z equal to 0. And I specifically said to you guys that when we look at this question, your focus is on the expression in the numerator. You know that 0 divided by any number, except 0, of course, in the denominator, will give you 0. All right? So that is why you focus primarily here on x plus 1 and you equate that to 0. Your focus is on the numerator with this particular question. Okay? Your focus here for z being what? Being equal to 0, because you've got a fraction here. Your focus is on the numerator. But the next question where it says for which values of x is z undefined, you know it's any number divided by 0 in the denominator that leads to undefined. Therefore your focus is on the denominator. Okay, yeah guys, try so hard to not mind some of the people that comment here. We can't run away from people who are going to comment and say it's holidays and all of those things. Okay, I hope that makes sense. Okay, so guys, I'm actually, this one, you know, the important thing here is understanding the concept about equal to 0 for a fraction, that our focus is on the numerator and equating it to 0, and undefined for a fraction because our focus is on the denominator. Okay, I hope that makes sense. Okay. No. This who's this guy? This app? No, that is not true. That is very false, my friend, what you are saying. Okay, what you are saying is very false. Okay, let me just address something that someone is saying here in the comment section. There's this guy and he's been saying this. I've been ignoring him on purpose, but I can see he's insisting. Okay, this app, you first and foremost, I'd love to, maybe before, I'm not even going to address this, let me not address it. Let me know in the comment section what grade you are in, and then I'll address you. Just tell me what grade you are in first. What grade are you in first? Because you have a misconception. Negative numbers under a square root don't make a function undefined. That is false. Okay, you have two concepts confused. And if you were here for my first lesson, then you would have been clarified. But firstly, maybe you can let me know, this app, what is it? This app was also my idea. Yeah, this app was also my idea. Comment in the comment section, what grade are you in? What grade are you in? Because I'd like to clarify the misconception you have at your level. You're doing engineering, all right. Now listen, this app. You see, when I first did this lesson, I explained two concepts, and even you now, you must pay attention. Pay good attention, please. Okay. This here, maybe you can tell me. The square root of -5 is equal to what? What is the square root of negative? What is the square root of -5? Imaginary, thank you. All right. Thank you. Non-real or imaginary. Thank you. That's very important. Then, a number divided by 0. What is that? Yes, your calculator, when you guys put this in, you will get maths error. That's true. Okay, but I want to clarify this misconception because I love the fact that an engineering student, this app was also my idea. I think he's also designed an app there, which is very nice. I'm sure he can give us some nice things there. Then we have 6 divided by 0. What is the answer there? I see everybody else is answering. I just want, this app was also my idea to also answer me in the comment section. I really appreciate it. Undefined, thank you. This app, non-real, is not the same thing as undefined. These are 2 separate concepts. You should know better. You are in university, you are doing engineering. When you know that this falls under the concept of complex numbers, you know that, and learners are able to attach meaning when they go to varsity, where negative numbers are under a square root. This is non-real. Undefined and non-real are not the same thing. So when you say what you are saying in the comment section and you hold to it and you are saying, no, even every number less than -1 is undefined, no, then you are missing the concept. The concept of undefined has to do with division by 0. All right. So for us high school students who are still in high school, who haven't gotten to the level that you have gotten into, we need to understand this and separate the 2 concepts because they are not the same. Your calculator will give you maths error, even this one. Yeah, for division by 0, you'll get maths error. Negative number underneath a square root or any even root, by the way, any even root will give you maths error. But this means non-real or imaginary. This means undefined. These 2 are not the same concept. They are separate, different concepts, right? And this is what I explained in my first video, or in my first live session with the grade 10s, because I don't want this confusion. This confusion, if it is there in grade 10, let us make sure that we don't have it. All right, let everybody else have the confusion, but we refuse to have that sort of confusion between non-real and undefined. Non-real means negative numbers underneath a even root. Okay, and like I said, guys, when you go to varsity, you know, in actual fact, I think those who are doing IEB maths, they actually, I think, already touch on that, you know, and go deeper into that concept. But for us, please, guys, don't ever make the confusion between these 2. So when I talk about undefined, I'm specifically talking about division by 0 in the denominator. It is not imaginary or non-real. We are not talking about negative numbers under a square root, please. All right. So I hope that answers you. This app was my idea. This app was also my idea. All right. Yeah. Maybe you can share with us the app that you've designed. That was your idea. Okay. So please, guys, as I said, x is equal to 3, x is equal to -2. These are the 2 values when substituted in the denominator, which will lead to there being a 0 in the denominator, and therefore it satisfies this condition that we have here. The values of x for which z will be what? Will be undefined. Undefined means division by 0 in the denominator. Hence we take the expression in the denominator, equate it to 0, then solve for x. That is basically the concept behind undefined. Okay, thank you very much. I hope it's clear now, and I don't ever this app was my idea. It would be nice if you could also just comment in the comment section if you are still here. I don't know if you are still here. You've gone silent now, but it's a very important thing. Don't confuse undefined and non-real. Okay, this app was also my idea. Well what? Okay, remember, guys, I'm not maths. Okay, this app was also my idea. You are not maths. Maths is a concept that is even outside of us. So literally, if I was teaching people the wrong thing, I would be happy to admit that no, I'm speaking absolute nonsense. But if really and truly what I have just said here is confirmed, all right, then basically what's important here is us accepting the concept in mathematics and aligning ourselves and being humble enough to just accept that, okay, this is what this means. So please, guys, undefined and non-real, separate concepts, okay? This app was also my idea. I think you are going to confuse my learners that are here, all right? I think if you want to actually have an opportunity to teach, please go teach outside my live. I beg you, my friend. I think that is allowed. You are going to confuse people here, guys. I know that sometimes there are people that come into this live that are not learners. They are just here to sort of like it's called spamming, and also they are just here to navigate and see what am I doing and so forth, and then they come with their smart ideas and they comment in the comment section. If you guys feel that you can teach, then go and start your own little classes in using TikTok. And please, guys, because you are going to confuse learners that I'm trying to clarify concepts to. This year, I don't want that thing. Yeah. Like I said, if I'm wrong with something, I'm more than happy to correct myself, even for the benefit of the learners. I'm not perfect in mathematics, but there are things that I know for sure, because it's not just a result of me having taught this thing once or twice or 3 times. Guys, there's a reasonable number of years of teaching that I've had, and more than that, also consulting others, authors of books and mathematical books and so forth. So it's not just me teaching, but it's also accompanied by a bit of research there and there. Okay, let me come back now. And I'm sorry if there's been a distraction, but like I said, guys, let's just go back to what I was saying initially. Initially, I said to you guys that z is equal to the square root of x plus 1 in the numerator over x minus 3 into x plus 2. The question was, for which values of x is z equal to 0? And remember, what I said to you guys is that when we have an expression and it's in fraction form, and look, we have z is equal to that. Z is this. This is z. Are we together? So we want the values of x by which z will be equal to 0. So if we were to be practical, because z is a fraction, we know that if there was a 0 in the numerator and there was any other number in the denominator, 0 divided by any other number will give us an answer of 0, which means z will be equal to 0 if at the numerator we have 0. So then if we come to the expression, we know that, okay, in the numerator we need to have what? 0. We take the expression in the numerator, which is x plus 1. We take it, we equate it to 0. Why are we taking the expression in the numerator and equating it to 0? It's because, Kaloku, we understand that for a fraction, in order for us to have an answer that is 0, 0 must be in the numerator, not in the denominator. 0 must be in the numerator. So therefore, for the expression, we take the expression in the numerator, we make it equal to 0, then we solve for x. Therefore, x is equal to -1. If you go and substitute this -1 back to the expression, just to verify and check that you've done the right thing, what is -1 plus 1 in the numerator? Doesn't that give you 0, guys? Even if you have a square root, because the square root of 0 is 0, doesn't that give you 0 in the numerator? Yes, it does. So therefore, it's x is equal to -1 that will meet this condition. Okay, so once again, what did the question ask? For which values of x is z equal to 0? So therefore, your focus should always be in questions like this. It should be in the numerator, taking the expression in the numerator, equating it to 0, then solving for x. Always keep that in mind. Okay? Always keep that in mind. We take the expression in the numerator because we understand that it is 0 divided by anything that gives us 0. So we take the expression, we focus. You see the 0 where? In the numerator. Then we are supposed to have what in the numerator? 0. So we take the expression x plus 1 in the numerator, make it equal to 0. Then we check what is that value of x that we will need to get 0 as a whole in the numerator. It's x is equal to -1. We solve for x. We know how to solve for x because in grade 9 and in grade 8 we learned how to solve for x. X plus 1 is equal to 0. We simply take the plus 1, crosses over the equal sign, becomes -1. So therefore the answer is x is equal to -1. That's it, guys. That's that. That is it. That's how we get to find the value of x, okay, for which z is equal to 0. Let's look at the next question. The next question says, for which values of x, we are still focusing on this, guys, for which values of x is z, this time round, is z undefined? What does undefined mean? Okay, I've just had a big argument with someone who's an engineering student about undefined and what undefined actually means in the context of mathematics in this high school level. And I clarified and I explained that undefined, guys, means any number divided by 0. All right, this is not me speaking, guys. This is mathematical textbooks, concepts, research. This is not my ideas. I'm not speaking my ideas, guys. So any number divided by 0, that's what undefined means. I repeat, any number divided by 0, that's what undefined means. Okay, does that make sense? Yes, Mushi. I like what you are saying there in the comment section, Mushi. Any number in the numerator divided by 0 in the denominator is undefined. So the focus is that the 0 now in this case must be in the denominator in order for us to have a what? An undefined number. So that's why when we come here back to this z that we have here, our focus is not going to be in the numerator, but our focus is going to be where, guys? In the expression that is in the denominator. What is the expression in the denominator? It's x minus 3 into x plus 2. So let us grab that x minus 3 into x plus 2. Let's grab it. There it is. And then let us do what to it? Denominator 0, we equate it to 0. And here on this side, I have what I call the steps to solving a quadratic equation. My beloved grade 9s, you guys learned in grade 9 how to solve a quadratic equation. Okay? And I just want to sort of like remind you that a quadratic equation is an equation guys, is an equation that has as its highest exponent the exponent 2 for your x variable. Ax squared plus bx plus c is equal to 0. This is the standard form of a quadratic equation. Are we together? The standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. So we have a quadratic trinomial equation here, which usually when we are given that quadratic trinomial, we go the step after writing it in standard form of factorizing it. When we factorize it, we usually have what? 2 brackets that we open to factorize it, and then there is a 0 on the other side. That is called our factors of the standard form. After finding the factors, we usually apply what we call the 0 factor law. And the 0 factor law, guys, is simply this. It says if a times b is equated to 0, in other words, if you have a product of factors equated to 0, you can then say the following: A is equal to 0 or B is equal to 0. A is equal to 0 or B is equal to 0. So you see here, you have x minus 3 into x plus 2 is equal to 0. This is already in the factor stage. We are here, guys. We are in this stage. We've passed standard form. We are here in the factor stage. So after the factor stage, we need to apply the zero factor law. What is the zero factor law? If you have 0 on the other side, guys, and then you have a product, a multiplication of two factors, you take the first factor, you make it equal to 0, then you put or. You take the second factor, you make it equal to 0. So that's what we've done here. We have x minus 3 multiplied by x plus 2, because brackets mean multiply, two factors. So we can take x minus 3 when we apply the zero factor law. 0 z factor f law L. We take this bracket, make it equal to 0, or there's that or. We take the other bracket, we make it equal to 0. Guys, this law is only applied when there's a what? When there is a 0 on the other side. When there's a what? When there is a 0 on the other side. We don't apply the zero factor law if there's another number here. No. We apply it only when there's 0. We take and we now can do what? We can solve each individual equation. X minus 3 is equal to 0. Take the minus 3 over. X is equal to 3. We call the solutions our roots. Then you take x plus 2 equated to 0. You take the plus 2 over, it becomes negative 2 on the other side. These are your two values of what? Of x. For which what? Z will be what? Will be undefined. Are we together? Hey guys. Are we together? Are we together here? These are the important things. Yo. Yeah, I know guys, the music is going on in the background, but I hope you guys are good at listening with music on the background. It's not even that interesting, the music, and it's unfortunately music I cannot even switch off because there's someone who's deciding that all of us must listen to it, you see. Yeah, hopefully it's not distracting that much. Yeah, so there guys, undefined. So I hope the concept of undefined is falling within your heart and you are internalizing it. Because guys, let me tell you this, grade 11s and 12 tend to forget this concept, and then it shoots them in the foot in other things that they have to do in later grades. So when as a grade 10 learner who is here, who is going to grade 10 and wants to do pure maths next year, you cannot play around with misunderstanding the concepts that we are talking about here. Are you with me? Please guys, don't misunderstand the concepts that we are talking about here. Please take them into your heart and internalize them. All right? Please, so that maths can be easy to you and you can get your distinctions easy, 100% in term 1, even if you want. It's up to you. You must decide. All right, here's another question. It's looking at us. Ooh, let's see. T is equal to the square root of 8x minus 24. Okay, I almost want to say that I think I don't necessarily want to do these questions yet. The reason why that is the case is because they need another concept to be covered. And I'm not going to cover that concept as of yet for you grade 10. So I'm going to leave these questions for now until further notice. All right? Yeah. Now that we are good, we have covered the numbers and number system for grade 10s. And guys, I do want to encourage you, if you did miss my first lesson for for grade 10. It's there. You can go to my YouTube channel. The link is in my bio. Maths is a Game is the YouTube channel. There's a maths lesson live lesson that I did for grade 10s, which was the first lesson. This one is the second one. All right, take some time and go and check out that lesson, because I do sort of like the introduction of the grade 10 syllabus, the things that you need to know at the beginning. All right, we can't find the link, but the link is in my bio. What do you mean you can't find the link? All right, Lindeland, don't worry. If you can't find the link, it's not in my bio. Then I will, after I'm done with this live lesson, I will put up the link for my YouTube channel. But the YouTube channel, the same profile picture that you see here is the same profile picture that is on the YouTube channel. Okay, Maths is a Game 5 to 7. That is basically and Maths is a Game is together. You know, it's not separate letters, but it's together. Maths is a Game. So I'll post up the link after I'm done with this live lesson. Okay, so then the other thing we need to know well, which you guys did very well in grade 9, is products. And I'm sure I'm speaking to those who are converted here. You guys should know how to simplify and how to factorize. So the first few questions we are going to do here have nothing to do with this topic yet. We are going to do this one after we are done with products. But guys, I'm not going to do factorization today. We are just going to look at products for now, and we're going to see how far we can go. Okay, guys, for products, okay, simplification of products. You guys did this in grade what? Grade 9, grade 8. So all of you should be like, I say, Tina, we know what to do here. No problem. All right. I'm just going to say that it's important for you guys, when you are dealing with products, to know the following. This is your friend in grade 10. Yes, from grade 8. Very good. This is your friend, guys. Do you see what this word is? BEDMAS. BEDMAS. Okay. What is B? Brackets. E? Exponents. Okay. D? Division. M? Multiplication. A? Addition. And then lastly S? Subtraction. Guys, this is the order that we need to move in whenever we are dealing with an expression with many operations. Our primary focus must first be on the bracket. Deal with what is in the brackets if one is able to. You move on to your exponents. In other words, if outside a bracket you have an exponent, if you cannot do anything with what is inside the bracket, but there's an exponent outside the bracket, deal with that bracket with its exponent and apply the required method. Okay. And I wish to also say that with exponents, let us remember S and L. With division, let us remember S and L. With multiplication, let us remember S and L. And then with addition and subtraction, let us remember that we only add or subtract like terms. In other words, we only can add and subtract only those terms that have the same uniform. In other words, they must have the same variable and exponent. We cannot add or subtract unlike terms. The terms need to be like in order for us to subtract them. So this, for me, guys, is like a summary of what to do whenever I'm dealing with products. Brackets, very important. You follow it up with exponents. Don't forget S. Mushi has just explained to you guys in the comment section what the S and L stands for, because some of you might be like, what, S and L? I usually see that in the movies. You know, those movies that you shouldn't be watching. But the S and L there means S is sign, N is number, L is letter. So when you are applying an exponent, you must apply it in the order of, you first take care of the sign, then you take care of the number, then you take care of the letter. When you are dividing, you take care of the sign, then the number, then the letter. When you are multiplying, you take care of the sign, the number, then the letter. Then when addition and subtraction is there, you must take note, do I have like terms? If you do, you can add and subtract them. If the terms are not like, they are unlike, you leave the terms as they are. This, guys, summarizes what we need to do with products. Hi, guys. If and please, guys, you can't start with subtraction, but there's brackets and exponents that need to be dealt with. The order matters. We start here, 1, 2, 3, 4, 5, then 6. We do not ever start where we shouldn't start. So look at this question, for instance. So in your head, what's happening? Bed mass is floating in your head. You need to simplify 5x minus 3x into 6 times 2x. So this is x. This is a multiplication sign, all right? That's not x, and then that's 2, that's x. Okay, so I'm very interested. Maybe in the comment section, you guys can go ahead and you can actually go ahead and tell me what you think. Wow, maths is always surprising and amazing. Thank you for this chat. You're welcome, Left K Codes. Thank you. 5x minus 3x, brackets, 6 times 2x, close brackets. Okay, you guys can actually go ahead and solve this for me, and you can write in the comment section your answer. All right, I will follow it up with going through the process step by step, and then we can see if we have the same answer at the end. Sbulela Williams, we acknowledge the patience, appreciated. Thank you, Baba. This guy, Willy, Mr. Mayor Willy. Yeah, to grade 12 we go, Sbulela. To grade 12 we go, hey? Mau. Okay, Left Cakes, I see your answer there. Left Cakes has an answer. Thank you so much for your answer there, Left Cakes. Yeah. Go ahead, guys. Solve it. I'd love to see what your answer is. The music, man, kills me. Hazy. Aibo, Q. Which Q is this one? Oh, come on, it is fine. Oh, okay. Yeah, I see your guys' answers there. I see your answers in the comment section. I see you guys. I see you. I see your answers there. I see your answers. I appreciate your answers, guys. I appreciate them. They are not left unnoticed. Okay. In the next 2 minutes, I will look at it and see if we have similar answers. But for now, I'm just gonna give people a chance to give it a crack. You know. I see others are complimenting and commending others in the comment section, which seems there's obviously definitely similarities in how we are seeing things, which is great. I love that. Yeah, school was over, but our minds are open. Remember guys, schools are closed, but our minds, they are not closed, they are open. Jordan Pina, something to think about. Yeah, school is not over. School will never be over, but yeah, depends on how you envision school. But schools, as per the governmental organization, institutions of learning, those are closed, but our minds, they are very much open, eh? Okay, I see you guys' answers, guys. Thank you so much. I see you. I see your attempts. Very nice. I love it. Okay, let me just let's unpack this then together. Thank you so much, guys, for your answers. So we have 5x here minus 3x into 6 times 2x. Now the thing is, what do we think about here? Bedmass. So first and foremost, with bedmass, we say brackets. Okay, brackets. So that means 5x needs to chill for now. Okay, chill. Minus 3x, and also the minus 3x can chill outside here for now. Let us attend to what is inside here. What is 6 times 2x? Because we can deal with what is in the bracket. What is 6 times 2x, guys? That's what I want from you guys. What is 6 times 2x? Okay, remember, when you multiply, you consider the multiplication of the signs, the number, and the letters. Okay, so yes, deal with the brackets. When we are dealing with the bracket, inside the bracket we have multiplication that can be dealt with. So what's 6 times 2x? This 6 is positive, the 2 is positive. What is positive times a positive? That will give us a positive answer. That is the sign, a positive sign. We move on to the number. 6 times 2. What is 6 times 2? It is 12. It's a positive 12. Then we have an x there, which is the variable or the letter, multiplied with no other letter. That means the x gets combined with the positive 12x inside the bracket. So can we say that the bracket has been taken care of? Definitely. Inside the bracket we got 12x. Are we together? All right, let's move on. After brackets, exponents. Do we have an exponent? No. Division? No. Multiplication? Okay. Bracket. Brackets mean multiply. Brackets also mean what? Multiply. So that means there's a relationship between the negative 3x and the 12x. Because remember, in our order, brackets first, exponents, division. We don't have exponents, we don't have division. Multiplication we have in the form of a bracket. So this negative 3x is to be multiplied with 12x. So when we multiply, guys, because of the bracket, what do we consider when we multiply? The sign, the number, the letter. Let's do that. 5x, chill for now. I'm gonna attend to you. For now, I need to deal with negative 3x. Brackets mean multiply. Negative 3x times the 12. So we multiply the sign, then the number, then the letter. So let's go. What's a negative times a positive? A negative times a positive, guys, is a what? A negative times a positive gives us a negative. Then we move on to the number. 3 times 12. 3 times 12. What's 3 times 12? 36. Then we move on to the letter. X times x. Now in your head, you guys should remember that when you are multiplying a variable where the variables are the same, what do we do to the exponents? Remember, there's a invisible ghost there. All right. So when we are multiplying same bases, we keep the base, we add the exponents. So that is 1 plus 1, which is 2. Guys, do you see what we have now? 5x minus 36x squared. How many terms in the expression? We have 2 terms in the expression, because terms are separated by a plus and a minus sign. But when we look at this, we are now here where we have to subtract. Can we subtract these 2 terms? That's the question. Can we subtract these 2 fractions? These 2 terms. I'm saying fractions now. Can we subtract these 2 terms? Okay, no. Why? Why can't we subtract them? Thank you, Ms. Zim. They are unlike terms. They are not like terms. Therefore, we can leave the answer in the following way. Right? I know some people would insist on leaving the answer this way. Doesn't really matter, guys. We would leave this answer this way if we were asked specifically to leave the answer in descending powers of x. Do you guys know what descending powers of x mean? This 36x squared is negative. This 5x is positive. The exponent 2, and then obviously there's an exponent here that is 1. That's what we mean by descending. Descending means 2, 1. We are going down in our powers, in our exponent, specifically. Okay, so if they say leave the answer in descending powers of x, you would insist in leaving your final answer this way. But typically, if you leave your answer this way, guys, that's fine. There's no problem in writing the answer as 5x minus 36x squared. We do not subtract these 2 because these are unlike terms. What do we mean that these are unlike terms? It means that if we look at this term, it has x. We look at this term, it has x as well. But the exponent here is 1, the exponent here is 2. What makes these 2 terms unlike is the exponents. When the exponents are different, we say that even though there's x on both terms, we say that those are unlike terms. We're together. So we don't subtract anything. We just leave the answer in that form. Okay. Can I get an amen in the comment section? Is there anyone who's saying, oh man? Because if you are really like lost, please let me know in the comment section. Bed mass is important, guys. Bed mass is important. Mohorosi. You are thinking of factorizing this, whereas the question is saying simplify. When we want products, the answer, it is to leave it in its simplest form. This is the simplest form. If you go on further and you factorize this, it means you are leaving the answer unsimplified. This means simplified. All right. So please, guys, products, simplification, all right, does not require us that when we have an expression like this, we factorize. Remember, factorization would be done if it would simplify our answer even further. If factorization will lead to the answer being simplified further, we simplify. Which is why when you have a fraction in the numerator, if you have an expression in the numerator and the denominator, and the numerator can be factorized and you can cancel out things, you do that. Why? Because that simplifies the answer further. Okay. Does that make sense, guys? Okay, Sibomguni, the reason why it was called board mass is because exponents were not a prominent feature in your lower grades, you know. So it was okay for you guys to talk about board mass. But the reason why I insist on bed mass is because exponents feature a lot when you are dealing with expressions with variables and exponents. Are we together? Yeah, so we change our tune a little bit. Okay, all right, let's look at this following one. Cloud, yes, you can. You definitely can. I don't know if you've been joining my live sessions, but for grade 11s, I started exponents, right? For grade 11, I think I've done 2 live lessons on exponents, and because you guys start with exponents and surds in grade 11, but in those videos, I did not jump into grade 11. What I did is I literally did revision on grade 8 and 9, and did a lot of problems, and I've been doing a lot of problems with grade 8 and 9 exponents. Why? Because the basics, if the basics are fine, I'm telling you, all right, in my next live lesson with grade 11s, I'll definitely get into grade 10 and grade 11 exponents, and then surds. And then if you've watched my previous 2 live sessions, the second live session was very long. I think I did a 4-hour live session with you guys. This was like the day before yesterday, all right? And grade 12s were here, and we were doing the things here. It was crazy. So yeah, you can check out that. Okay, 5x minus 3x. Okay, but guys, it's this poor quality live lessons on TikTok, because I upload my live lessons as raw as you see them as they are. But I think if you are patient and you just allow yourself to learn, I'm telling you, forget about the prettiness and the quality, but if you just listen and you follow along, you should be fine. 5x minus 3x into 2x squared minus 3x plus 4xy minus 2y squared. I think you guys I'll give you a chance to do this one as well. Let me not jump and do it myself. You guys can take some time, do this one, and let's see what you guys come up with. Why are you not doing maths, Zainab? Giving people a chance to do this problem that you see before you, the one that says 5x minus 3x. Which grade are you in? Which grade are you going into? 2x squared minus 3x. No, the thing is, you are on holiday. We are not. We are also on. In actual fact, let me just say we are also on holiday, but we are choosing to also utilize a part of our holiday to actually doing maths. I think that's the difference between us and you. I see your answer there, Miss Sim. No, the neighbors didn't decide to go to bed. I just muted. I'm trying to also shut out the music for you guys. I don't know how agitating it is, but if I'm getting agitated, I can only imagine you guys are listening from. Grade 10, which is also relevant for grade 9, of course, because you guys do this in grade 9. But this is grade 10, term 1. Just trying to get these learners exposed to some of the content they'll be. Good for you. not been doing maths this holiday. Oh well, that's okay. That's okay. Hopefully we can sensitize you. You can jump onto the bandwagon, buddy. Yeah, guys, please don't stop double tapping on the screen there, especially people that are just sitting here. I know some of you are not really here for grade 10. You are just here because you are here. Please don't stop tapping on the screen. I need those likes. I need those likes there, and I need all the other things that you guys think are fitting for this live. Don't deprive me of things that you think are due, please. Yeah, people are working nicely there. I can see you guys. You guys are working very nicely. Okay, so let's look. So once again, what are we looking at here? BEDMAS. Brackets, exponents, division, multiplication, addition, subtraction. That's all. Brackets, we can see the brackets there. Now the question is there anything inside the brackets that we can add and subtract? Because you can see there are how many terms inside your bracket? There are 1, 2, 3, 4 terms inside the bracket. Is there anything that can be done with any of these terms inside the bracket? That is the question. That's what we need to first think about. All right, remember initially here there's something we could do, but here, is there anything we can do with what is inside the bracket? And the answer here that I see in the comment section is no. You are 100% correct. Why is there nothing we can do inside the bracket? Why is there nothing? There are no like terms. Thank you so much, Sipomgun. There are no like terms. 2x squared is different from 3x, is different from 4xy, it's different from 2y squared. There's no like terms at all. So then what do? We move on. Exponents. Well, we have exponents for individual terms, but that doesn't help with anything. Division. All right, Zainab, you are more than welcome to leave the live, my dear. The minute you see something is very boring for you, please leave the live. Don't stay around if you are bored. Okay. Division, there's no division. Move on to the next thing, multiplication. Well, guys, multiplication, because division won't help either. Multiplication, let's remember, brackets mean multiply. We've established that. Brackets mean multiply. So who is the lucky guy who's going to get multiplied here? It is negative 3x. Okay, thank you, bye. Negative 3x. Please guys, if you are bored, please leave. Please don't stay if you are bored. Don't stay. I also, if I was bored myself, I wouldn't like to be here. Please guys. So here we have negative 3x, right? And it has a relationship with the 4 terms inside the bracket. So what are we going to do, guys, with the negative 3x with the terms inside the bracket? We are going to use what we call the what? We are going to use the... I want someone to tell me what we are going to do. What are we going to do, guys? We have negative 3x. It has a relationship with the bracket, which means multiply. So the negative 3x, what are we going to do with it for the 4 terms inside this bracket? Remember, this is like a 1 term, and inside here we have 4 terms. So what do we do with the negative 3x? Thank you, Mushi. We will distribute negative 3x to the 4 terms inside the bracket. So we use what we call the distributive law. I love this. I love it when learners say the things that need to be said. We are going to use the distributive law. So 5x is going to chill for now. Wait for the man of the house to unlock. All right. And I'm sure the man of the house is dressed in Father Christmas clothes. What he's going to do is going to distribute gifts to each individual family member inside the house. Distribute what? Gifts to each individual what? Member that is inside the what? The house. So we are going to multiply. When we multiply, what did I say to you guys? When we multiply, we must remember who? SNL. We multiply the sign, the number, the letter. Everyone gets a gift. You get one, I get one, everybody gets one. Yes, negative 3x. It's like when all the 119 people in this life decide to give me a rose as a gift. That's they distribute their individual gifts to the one person who's actually in the life. That's basically, like, in essence what I'm saying here. So we don't forget what sign, number, letter. So we're going to take negative 3x and distribute it to 2x by multiplication, because brackets mean multiply. So we're going to say negative times a positive. You see these things? Negative times a positive, negative. 3 times 2, 6. X times x squared. Do you see? Sign, number, now the letter. X times x squared. Remember, there's an exponent 1 here and there's an exponent 2. So what do we do, guys? We keep the variable, we add the exponents. 1 plus 2. What's 1 plus 2? It's 3. So we have negative 6x to the power 3. The first gift has been delivered by the father to the mother. Okay. Thank you, Miss Sim. That's the same thing. Distributive law and multiplication of individual term to all the terms inside the bracket is the exact same thing. All right. So, Miss Sim, thank you so much for saying that comment. You are very much correct when you say that. Right? And guys, many times learners forget to take into consideration that this 3x is negative. So you are multiplying the entire negative 3x into the individual terms inside the bracket. So your statement, Ms. Sim, is 100% on point. I love it. I love it for you, and I love that manner of perception. You're perceiving it quite well. So your negative times a positive, all right? Your sign, then your number 3 times 2, then your letter x times x squared. All right, so you focus on that SNL as you multiply out for each individual term. You take that into consideration, right, so that all your terms can actually pan out correctly. So we do the same thing, negative 3x times the negative 3x. So a negative times a negative, we know that a negative times a negative is a positive. 3 times 3 we know is 9, and then x times x gives us, keep the base, we add the exponent, we get x squared. Remember, guys, there is that ghost invisible one that is there and there. Don't forget that. All right, so we get 9x squared. Ain't karab or not 6x squared, please. 3 times 3 is not 6. Ain't karab. 3 times 3 is not 6. Let's be very careful. That's where I say to you guys, please, if you know your mind is going to mess around with you with the multiplication, please have your calculator handy. Let your calculator be very close. All right, rather have your calculator close and then go ahead and say 3 times 3, so that when you punch it in, voila, you get the actual correct answer. Okay, please, guys, otherwise we cannot be messing up with these basics. If we are messing up with these basics, then it means we are basically just going to start a problem for ourselves. Guys, I want to say this to you, Great Dance. If you guys start problems for yourselves by not knowing what a negative times a positive is, by not knowing what 3 times 2 is, by not knowing what a variable that is the same multiplied together, that you add the exponent, when you start little problems like that and they start filtering in through your working out, that's where the danger starts being, because those little cracks, imagine a foundation, guys, that has small minute little cracks, that's not done properly. What happens later on when you are busy building and you finish the roof and you are done, but there's those small cracks are there in that foundation? I'm telling you, one day the rain seeps through, things happen, the rain brings the house down because your foundation was not solid. So you guys need to make sure that you are solid in your understanding. I'm trying to make things easy for you here. I'm saying use bad maths. When you use BEDMAS, you are using BEDMAS because you can see there's many operations in this expression. Okay. First, you look at the expression and you ask yourself, how many terms are in this expression? How many terms in total? Well, there's 5x, which is one term. Then you have a minus sign that separates this term from this one. This is 3x, but then the bracket, this here, all of it, this is one single term. Negative 3x into all of this is one term, right? So you have two terms in total. After establishing how many terms you have, you go to BEDMAS and you ask yourself, okay, what am I going to deal with first? Brackets. But is there anything to deal with inside the brackets? Well, if there is, you deal with it. If there isn't, then you don't. Then you ask yourself, okay, what's happening with the bracket with what is outside? You use the multiplication distributive law. And when you do so, guys, you see, I'm making things easy for you. When you do multiplication, don't forget S and L. When you do division, don't forget S and L. When you do exponents, don't forget S and L. These S and L is the key to so many things that you do in mathematics. You multiply the sign, you multiply the number, you multiply the letter. You divide the sign, you divide the number, you divide the letter. These are the things that you are doing. Okay? And when you are dealing with the signs, please know what happens with the signs when you multiply and when you divide. All right? Please know what you do with the signs when you multiply and divide. These are important things that you need to know. All right? So as I said here, 5x we write down because it's a term that's separate. It's there. Okay? Negative 3x we distribute. Okay? When we do so, we think of what? S and L. A negative times a positive is negative. We're done with the sign. We move on to the number. 3 times 2 is 6. We are done with the number. We move on to the letter. X times x squared. You keep the variable x. You add the exponents. 1 plus 2. So you have x to the power 3. That term is finished. You take negative 3x. You distribute it to the next term. You multiply because brackets mean multiply. Negative times a negative is positive. Your sign is done. Then your number. 3 times 3 is 9. Then your number is done. Then your letter. X times x is x squared. You keep your base, you add your exponents. 1 plus 1 is 2. Are we together? We move on. Take the negative 3, distribute it to the 4xy. Start with the sign. Negative times a positive. Negative times a positive. 3 times 4, the number. Thank you. Negative. 3 times 4. That's the number now. Now you are moving on to the number from the 3 times 4. Thank you. Then you move on to the letter. X times x. Well, those can be taken care of. X times x. Exactly, Pori. Thank you, Lindelani. Thank you, Sipo. You know, x times x, x squared. The y is alone. But you know what? Multiplication combines the letters. You see? So we have x squared, y. Does that make sense, guys? I mean, we are doing this step by step. Daddy is busy distributing Christmas presents to the 4 individual members that are in the house. Daddy now wants to distribute his last Christmas present to the last child in the house. Negative times a negative. Okay? Negative times a negative. You see, guys? We're poor. You see? 3 times the 2. You see? 3 times the 2. Yeah, Pori, MSM, thank you so much. Then x times y squared. Exactly. X times the y squared. X times the y squared. They combine those two because multiplication combines x, y squared. You see? And what did multiplication do? when we distribute it, it removes the bracket. The bracket is now gone. Because when we distribute an outside, okay, an outsider, when daddy begins to open the house and distributes the presents, yeah, it's like, yeah, we open everyone, open everything, okay? Then all that is left for us to do is to look at how many terms do we now have, because the brackets have been removed. Okay, we have how many terms there? Yeah, package is gone. Very true, King. The package is gone. We have 5 terms. Question then is, we go back to bed mess. We did B. Exponents was not there. Division was not there. Multiplication, we are done. We used S and L. We move on. Addition and subtraction. When we add and subtract, what do we actually add and subtract? We only add and subtract like terms. Are there any like terms that you can see here? Because if there are, then it means we need to add and subtract them. If there are not, then it means we are done. Thank you, Sipho Mguni. That's the answer, because the terms are unlike. There are no like terms, guys. They don't exist. I know some people are very, it's like people are tempted. They're like, come on, sir. Can't we say these two are like terms? No, guy, look at X. Here's a 2. Look at this X. Has a 1. Look at this Y. It has a 1. This Y has a 2. Not like, sir, what about these two? Sounds kind of close enough. This is X squared. There. You see, it's X squared. Can't we do something here? Surely X squared. Can't we do something here? Say, Aibo. Say. Something here. Something's fishy here. Alright. And the thing is, guys, the Y makes it different from this one. So therefore, these are also unlike. There's no other like term that we have here. So that means the answer is simply this. Okay? Exactly, level dealer. The exponents make a difference. Different variables with different exponents means the terms are not alike. Okay, that was actually me in grade 8 before joining your lives, is it? Moji. I know, hey, I know. But once we get the nonsense out of the way, and we are clear about what needs to be done, then we no longer find ourselves doing those things that we once used to do that were nonsensical. We start doing things the right way, and then it informs, you know, how fluent we are in mathematics. And that sort of fluency builds a lot of confidence, and that sort of confidence definitely yields the sort of results that we think we deserve. Okay, so yeah, please guys, otherwise it's very sad for me when I see funny things being done. Here's another one. Okay, the famous question we need to always ask is, how many terms are in the expression? We need to always ask that question. It's a very pivotal question to ask. How many terms are in the expression? Okay, very important opening question. How many terms are in the expression? No Pinky. Thank you, No Pinky. No Pinky, you are amazing. Miss Zim, definitely. 1 beautiful term. Mushi, not 2. Why did you say 2? Let me ask you, Mushi, why did you say 2? Okay. Remember, guys, the relationship between negative x, the bracket, and this bracket, the entire relationship we are seeing here is one of what? Of multiplication. So it's negative x multiplied by x minus 2y multiplied by 4x plus y squared. Okay, yeah, it's almost like saying negative 1 times 2 times 3. Now I know all of you know how to multiply this. Okay, all of you would be confident in telling me what the answer is here. In fact, can you guys tell me what the answer is here? Negative 1 times 2 times 3, what's the answer? Thank you, Fajar. I really appreciate it. I am madly in love with the people that are here. You are right. I am mad. 1, I'm madly in love with the people that are here in this live. I madly love them to the extent that I am doing mathematics now. So you are right. I'm very mad. Very, very mad. Very, very mad. Do you actually know what mad means? It means make a difference. So that's what I'm doing. Make a difference. Fatar. So thank you so much for acknowledging how mad I am. I'm making a difference. 1 times 2 times 3. Yes, Miss Zim, you are 100% correct. A term is separated by a plus or a minus sign. Division and multiplication do what? They make it one term. Okay, very much so. I think Fatar is a very rude man, so let me just block him nicely. Otherwise, it was nice that he came through for the little time that he was here. Yes, guys, the answer is -6. Okay, it is -6. Okay, Donald S, I'm not understanding you. What if the larger number is on the left hand side? I'm not understanding you there. But yes, it's -6. Why do we say that? It's because you take the -1, you multiply it by 2, you get the answer. What's -1 times 2? It's -2, right? Then that -2 is the one that you take, then you multiply that -2 with 3, you get -6. So I think the logic that we have applied here is the same logic we are going to apply here. You see? And honestly, guys, there's no one way of doing this question. There's, depending on who's doing the question, you can do it in one of 2 ways. The way I see it, you can do it in one of 2 ways. In actual fact, you can do it in one of 3 ways. Okay. Yeah. Thank you, Kanye. Thank you for answering that question. Okay. Donald was asking about if the large number is on the left-hand side. Or in other words, if it was 3 times 2 times -1. Or let's say it was 2 times 3 times -1. Remember, guys, multiplication. What do we say about multiplication? We usually say multiplication is from grade, I think it was grade 8. We say multiplication is commutative. What does commutative mean? The order, guys, doesn't matter. Okay, the order in which you place those numbers doesn't matter. The answer will remain the same, because multiplication is like that. Multiplication is not dependent on the order in which you place your numbers. The answer will fundamentally be the same. We say multiplication in mathematics is commutative. That's the word. The concept is the commutative nature of multiplication. Okay, so there are 2 mathematical operations that are commutative. It's not only multiplication that is commutative, it is also addition. Addition is also commutative, right? In that if you have 1 plus 2 plus 3, it's the same thing as 3 plus 2 plus 1, which is the same thing as 2 plus 1 plus 3. Addition is also what? Commutative, right? So the commutative nature of addition and multiplication. So I hope that answers you even that much more, Donald, that numbers in our operations, when we multiply, we say that the numbers, or we say that addition is commutative, we say multiplication is commutative. Okay, thank you, Kanye. No man, Kanye, you passed metric around about the same time as I did, so we are together there. High five to you. -x into x minus 2y into 4x plus y squared. Thank you for your comments as well, Kanye, in the comment section. Really appreciate you a lot. Actually, sis, you've touched my heart, because that is basically the year I matriculated as well. Okay, here guys, here -x into x minus 2y into 4x plus y squared. Can we get rolling and cracking here? Yeah, she definitely ate big time, left no crumbs. Iconic C, yeah. No Pinky says foil. Okay, so remember guys, I said to you there's one of three ways to do this, all right? And the concept basically also springs forth from what I said here initially. So for instance, if I say -1 times 2, I get -2. Then I take that -2 I got from there, I multiply it by 3, I get -6. Or 3 times 2, I get 6. After getting 6, I take that 6, I multiply it by -1. That gives me -6. Or 2 times 3 is 6. I take that 6, I multiply it by -1, I get -6. So do you see in essence what we are doing? Because it can be the same thing that we do here. It really depends on who is doing the maths. So you could take this and multiply it with this alone first. You get the answer here. Then you take what you have, you multiply it with the 2 brackets. Or you could keep the -x, do FOIL with these 2, then take the -x later on and distribute it to what you have inside. It's really up to you. That's why I was saying that with multiplication is commutative. All right. So if we decide, for instance, to take -x and allow it to just be here outside, then we decide, let us apply FOIL. Okay, remember the distribution of 2 brackets. Okay, we should have learned this in grade 9. We apply a method that we call FOIL. What is FOIL? We multiply or we distribute the first term to the first term inside the bracket. Okay, then we take the very first term, we distribute it to the second term inside the bracket. So let's just look at the distribution first of x to 4x. Remember, brackets mean what? Multiply. And when we do this, we don't forget who? S, N, L. What don't we forget? Guys, S and L is everywhere. When we multiply out, we don't forget who? S and L. So let's multiply. A positive times a positive will give you a positive answer. Okay, S and L means we multiply the sign, then we follow it up with the number, then we finish off by multiplying the letter of the alphabet. Sign, S means sign, N means number, L means letter. So in other words, if you look at x times 4x, you have a positive 1 here that you don't see. Here you have a positive 4. So a positive times a positive is a positive. That's the sign. You move on to the number. 1 times 4 is 4. That is the number. Then you move on to the letter. X times x, that gives you x to the power 2. Remember, the negative x is still there outside. We're just dealing with the 2 brackets first, because that's what we are deciding to do. Okay, so x times 4x gives you 4x squared. In other words, positive 4x squared is what you get when you're multiplying x with 4x. First terms multiplied give me 4x squared. Then I move on to my outer terms. In other words, distribute the x to the second term now in the other bracket. Again, positive times a positive. Remember, this is positive. That gives me a positive. Then there's a 1 here that I don't see. There's also a 1 there that I don't see. 1 times 1 is 1. And then x times y squared gives me xy squared. Okay. Then that's the outer term. Applied S and L. Then I move to the inner terms. So now I'm going to move to the second term inside my bracket and multiply it to the first term in the other bracket. You see, I took x, distributed here and there. Now I'm taking negative 2y. Please guys, take note. I'm taking what? Negative 2y, and I distribute it to 4x. Then take negative 2y again and distribute it to positive y squared. All the way I'm multiplying, applying S and L. So that's my inner term, and then I multiply my last. Don't forget S and L. Don't forget S and L. So what's a negative times a positive? Sorry, what's a negative times a positive? Yes, multiplying this first. Negative times a positive is a negative. Then we say 2 times 4 What is 2 times beautiful 4? Yeah, the music is like, these guys are really getting into the celebration. Then y times x, the letters there. What's y times x? Okay, xy. Then lastly, we take the negative 2y, we multiply it by the last term inside the bracket. That's why we say last. Negative times a positive gives me a Uluvo dealer, oh my soul. Luvo dealer, hopefully my brother, ngeyakunceda wena, ngeyakunceda. Hopefully it will nceda the people that are here. I don't know if these learners actually really appreciate the fact that, because I'm trying so hard to make things simple for them, because these shenanigans, these gimmicks that I am utilizing here are gimmicks to try and help them when they look at a problem to not really have, complications, have ease, bad maths, SNL. These are just things to help. So yeah, I'm glad. Thanks for your comment. I really appreciate it. Now I'm losing my trail of thought. I was saying a negative times a positive definitely is a negative. Then we say 2 times 1, that is 2, and then the y times y squared, that's y to the power 3. Yeah, right. Now inside this bracket, when we look at it, do we have any like terms? Seemingly we don't. Now because we don't have like terms, guys, because there aren't any for the bracket, then all we are going to do now is we are going to take the what? The term negative x that is outside the bracket. It has a relationship with the bracket of multiply, and we are going to, yes Mushi, distribute. Miss Zim said we multiply the outside negative x with each individual term in the bracket. No, this is not grade 12. That girl Refi, this is grade 10. Okay, this is grade 10. Grade 12 is coming up. Half 10, guys. Sorry man, yeah, 10-ish. Yeah, the grade 10s and 11s will just have to forgive me. I'm going to alternate with you guys because yesterday or the day before yesterday I did grade 11. Today I'm switching over to grade 10, but grade 12 I'm doing every evening, 10 onwards. We see what time we end. 10 onwards, grade 12. Okay, sequence and series as well. So yeah, negative x, we distribute. You use SNL, so we are going to take and distribute each term. Negative times a positive, negative 1 times 4 is 4, and then x times x squared. Remember, when we are multiplying same bases, we keep the base, we add the exponents. There's an exponent 1 here, there's an exponent 2 there, we add the exponents, so it's 4x to the power 3. Then we do the distribution for the second term. Negative times a positive, we do the same thing. Negative 1 times 1, obviously that's 1, but the number doesn't matter because it's 1. 1 usually appears as a coefficient if there's no other variable there. But if there are variables, then we don't bother ourselves with really writing the 1. But if you do decide to write it, that's fine. I mean, it doesn't change anything. X times x, x squared. Y squared. Do the same thing here. Negative times a negative is positive. 1 times 8 is 8. X times x, x squared. Then the y combines. Negative times a negative, sign is positive. Number 1 times 2, there's a 1 here that we don't see, that's 2. X times y cubed, x y cubed combined, bracket removed. Are there any like terms? No. Leave the answer. in the state. Okay. All right, guys, that's that. Okay. That's that. Oh, that is that, guys. That is that. All right. And yes, someone else, if they would have wanted to, could have decided to do it differently. They take the negative x, they distribute it to just these first two, but then they keep the bracket. Okay. You get negative x squared. Guys, I just want to say, that's why I was saying to you that there is no one way of doing something. You could do it another way. More, sir, I need more. I'm going to show you more. I'm going to give you more to do for yourself. Okay? Because I think I'm going to end the live here. So think about it here. Someone else could do it like this. You take the negative x at 10 VKB. I'll start grade 12 at 10. Negative x into x, you get negative x squared. Negative x into negative 2y, you get positive 2xy. So you distribute the negative x for this bracket alone. You keep this one as it is. Then you FOIL these two. You'll get the same answer. You will get the same answer. All right. Yeah, that's why I was saying multiplication is commutative. You could decide to FOIL first, then you take the negative x and multiply it later as you did here. Or you could take the negative x, distribute. You're not going to distribute the negative x to both brackets. No, you distribute it to 1. Just like when you are saying negative 1 times 2, you take the negative 1, you multiply it with 2 alone. What do you get? Negative 1 times 2 is negative 2. Then you take the negative 2, you multiply it by 3, you get negative 6. So you do the same thing here. Take the negative x, you distribute it to this bracket alone. All right? Yeah. Then you get negative x squared plus 2xy. You keep the bracket. Then you FOIL these two. Guys, you'll get the same answer, man. You will get the same answer. You will get the same answer. Let me show you the same answer. Here it is. This times that, sign negative. Number 4. Letter x to the power 3. Take this one, distribute it there. Negative times a positive, negative. Number 1. Letter x squared, y squared. Take this one, distribute it with that. Positive times a positive, positive. 2 times 4, 8. X times x, x squared. And then the y, you just place it next door because it has no other friend. This times that, positive times a positive, positive. 2 times 1, 2. X, y to the power 3. Okay. so yeah, guys, like I said, really it's dependent on who's doing the question. At the end of the day, anyone doesn't matter. Guys, grade 10s, I'm going to love and leave you now. You can take a screenshot of these questions, do them on your own, just to sort of like check your skill. All right, I'll be doing these not tomorrow, I think the day after tomorrow, because I'm going to do grade 11 tomorrow, way before 10. Okay, but I'll be doing exponents for grade 11, but I'll be doing exponents for grade 10 tomorrow for grade 11, and then go into exponents for grade 11. So please, guys, you can take a screenshot of these, do them your own time, you do these. All right. Okay, just let me know if you guys have screenshotted this. I think I'll count to 5. It should give you enough time to screenshot. Then I'm going to turn over the page. There's another page of these problems which I want you guys to do. And then when I have the live the day after tomorrow, I'll start by doing these corrections. Okay? Yeah. And then I'll upload the video onto my YouTube channel, this one, for this lesson that I did today. And you can watch and rewatch it as much as you want if there are things that you missed, and make sure you have a solid understanding for yourself. And I also want to encourage you to go watch any other grade 10 videos that I have posted onto the YouTube channel ever since this December holiday, because there's other things that I've posted that are grade 10 related, which you need to know for when you start next year. And they will help you and they will assist you. And if you have any questions, you are more than welcome to send me a DM or ask me any question that you want to ask me or get any clarity. Okay? Yeah. Right. So hopefully you've taken a screenshot. Let me turn over the page. This is the last page of work that I want you guys to check and do on your own. Okay? You will specifically note that I have not with you guys done when you have 2 terms and 3 terms inside the bracket. But if you know the distributive law, you are going to know that, oh, okay, take x distributed to the 3 terms, multiplying using SNL, then take 3, that's positive, distributed to the 3 terms. Remove the brackets, get all my terms, add and subtract like terms. There's nothing much to it. You are just applying the distributive law using SNL, multiplying the sign, the number, the letter when you are doing the things. Okay, so yeah, you have a crack at that, and like I said, when we do meet again, I will actually be doing these. Yes, you know, Moss, you can always send the answers to my inbox. I think also people like Mushi, you should have been in my WhatsApp group for like forever. But guys, if you want to be part of my WhatsApp group community as well and stuff like that, so that you guys can have more ease in being able to communicate with me about specific things, it's just that, like I said, it's just a bit of a price fee that is attached to that. Just let me know and send me an inbox, and then we can negotiate and see. Yeah, we can take it from there. That's for the grade 10 specifically, because yeah, and that will also help for other things, because sometimes maybe you may want to ask a specific question, but it takes a long time before you see me in a live session, for instance. But if like you are there, then it's fine. Okay guys, thank you so much. I am going to love and leave you now, grade 10s. Thank you so much. I hope you guys enjoyed the session and you enjoyed the music as well, which I basically did not elicit or facilitate, but it was just there. Cheers guys, let me see you, let me love and leave you. Grade 12s, I'll see you at 10. At 10, grade 10, I'll see you at 10. Grade 12, sorry, I'll see you at 10. You're welcome. Have a lovely evening to you too, Kanye. You are actually now a familiar buddy now, because I guess you saying you finished your matric when you did actually, like, yeah, stirred something in my heart. Thank you so much though. Cheers guys, bye. And do these, please, do these.